Good day, students. Today we'll be looking at the MCQ questions for your practice paper. So first question, study the water cycle below. Which of the following processes describe process A and B correctly? So one thing that we know for sure is that we've given enough practice, we can straight away identify this as the water cycle. And we know that the water cycle is driven by two processes. The first being evaporation and the second being condensation. Right, so we will need to identify these two processes. So remember that prior to evaporation, the state of water should be in liquid form. So as we can see here, process A over here, what comes after process A is water vapor, and what is before process A is a liquid water. So process A would need to be evaporation. And then over here, remember that your clouds are actually made of tiny water droplets. So this is actually in a liquid state. So from a gaseous state to a liquid state, the process B must be condensation. So with that, we have already identified A and B. Okay, your answer would be number 4. Question number 2, ice changes to water at 0 degrees. This temperature is known as the what of ice? So remember, at 0 degrees, it is both the melting point as well as the freezing point. So therefore, whether is it referred to as the melting point or the freezing point depends on whether what is the direction of the change of state. So is it from ice to solid? Sorry, is it from ice to liquid, or is it from liquid to ice? So in this case, the direction of change is over here. This is actually from ice to liquid, from solid to liquid. So for that to happen, you will need to input heat, right? So this would be a melting process. So therefore, answer 4. Okay, next, which of the following actions help us to conserve water? This is a pretty straightforward question. Answer is 4. Right, you wash a fruit in a basin instead of a running tap, because if you leave the tap running, a lot of water will be wasted. Question number 4. Irfan prepared 2 similar cups A and B containing water of different temperatures. The 2 cups are placed in a room with a room temperature of 30 degrees. After a few minutes, Irfan saw water droplets forming as shown in the setup below. So this is an experimental setup. So in every experimental setup, there will be a change variable, okay, and a measured variable. So the change variable for this case would be your different temperature, and probably your measured variable in this case is what the amount or location of water droplets that you are observing. Now, for this question over here, always remember, when you see water droplets forming, it means that condensation has happened. Now, if let's just say, okay, the site on which the water droplets form would be the site that actually has the warm water vapor. So I'm just going to draw it in. So cup A probably has a higher temperature than 30 degrees Celsius, the liquid in cup A. Okay, and then after that, for cup B, as you can see, the water vapor is the warmer water vapor is probably at the surrounding. So when it touches the cooler surface over here, it condenses on the outside. And the opposite is true for cup A, whereby the warmer water vapor is actually inside the cup. So when it touches the cooler surface, it will condense inside. So probably for cup B, it has a temperature that is higher, that is lower than 30 degrees. So this one has to be higher than 30 degrees. This one has to be lower than 30 degrees for cup B. So with that, we can then take a look at answer to see what is plausible. So the only one that is plausible is actually number 4, whereby your cup A, the water temperature is higher than 30 degrees. Question 5. Mrs. Tan conducted an experiment using 4 identical cloths. She poured an equal amount of water into each cloth and exposed them to different conditions, as shown below. Which cloth will take the longest time to dry? So when you see the word dry, we already straight away can associate this drying process with evaporation, and time, that means rate, is here. So in short, they're asking you as a question on rate of evaporation. So with that, in fact, you can then link it to your factors affecting rate of evaporation, WET. W stands for wind, exposed area, surface area, and then after that, temperature. An increase in any of these factors will affect a faster rate of evaporation. So which one take the longest time? Longest means slowest, right? Has the lowest rate of evaporation. So looking at it, okay, comparing, the answer would actually be 1. Now, why is that so? In 2, we see that your cloth is spread out, so this increases exposed surface area, making it faster to evaporate. In 3, you have got the sun, whereby the heat from the sun, which is your temperature, which is your increase in temperature, will cause it to evaporate faster. Lastly, we have your moving fan, which creates your wind, that helps with the increase of evaporation. So the only one that slows down evaporation is actually number 1, whereby your cloth is crumpled up, reducing your exposed area. So answer 1. 6. Timothy stepped out of a pool. He was wet and shivering in cold. Okay, which of the statements below resulted in Timothy shivering in cold? Okay, A, water on his body evaporated and became water vapor. Answer is correct. Why? Because when you evaporate, you need heat, right? So where did this heat come from? It came from his body. So when you take heat away, when the water draws heat from Timothy's body to evaporate, you're actually making him colder. Next, water vapor from the surrounding condensed on his body. That's not quite right. Okay, why is that so? That's because if you take a look at it, okay, firstly, the wetness came from him being in the pool, not from water vapor condensing on his body. Okay. Secondly, we should also know that given the right context, his body temperature is about 37 degrees. And room temperature is probably about 30 degrees Celsius. So in short, he would not have provided a cooler surface for the surrounding water vapor to condense on him. So B is wrong. C. The wind speeds up the rate of evaporation of water on his body. Yes, that is correct. Okay, because the wind factor is here and we know that wind speeds up evaporation. So remember, this can also be linked over to the first point. Since evaporation requires heat being drawn for the body, a faster rate of evaporation will also mean that the heat would be then drawn from his body at a faster rate, so that your liquid droplets will be evaporated at a faster rate. So answer is 4. 7. The graph below shows how the temperature of water in each of the two beakers X and Y change over time as water in both beakers was heated. So based on this, the first thing we know is that this is a heating curve. Something that we need to actually identify when we are presented with temperature graphs. Is it a cooling curve or is it a heating curve? Heating curve is whereby as time goes by, okay, your temperature tends to increase. Okay. So based on the graph above, which of the following statements are correct? Now, whenever you look at a graph, please make sure you pay careful attention to the labels. So this is talking about temperature of your water on your y-axis, and then on your x-axis is your time. Okay, so let's take a look. Beaker A was heated over a stronger flame than beaker Y. So let's take a look. So beaker X is the one with the dark line. Okay. So as we can see over here, we know that X seems to have gotten at a higher temperature, to a higher temperature, okay, at a faster period of time. So yes, I would agree that it was heated over a stronger flame because it managed to heat a higher temperature within this amount of time, right? So if you take a look at it, when we're looking at the highest possible temperature, which is here, your X actually got to the highest temperature at a much faster time, which is over here. I'm just going to mark it down for you. But your Y, to reach the same temperature, took a much longer time, as you can see from here. So A is correct. Let's take a look at B. That beaker Y was heated over a stronger flame than X. That's not correct because this is the opposite of the first statement. So if the first statement is true, then the second statement cannot be the case. C. The temperature of water in beaker X took a longer time to reach its boiling point. Okay, so for this one, okay, let's take a look. This is false because as you can see, when it hits the maximum point and remain constant, it actually took a shorter time, right? So how do you know that this is the boiling point? Well, from this, I can see that this part over here remains constant. So this tells me that there is a change in state, probably boiling. Because during boiling point, temperature remains constant until all the liquid has completely boiled off. Okay? So this is false. Lastly, the temperature of water in Y took a longer time to reach its boiling point. This is true. Okay, because once again, if you take a look at it, Y took a longer time as compared to X to reach the same temperature. So our answer would be number 4. Okay, and that's about it. Thank you.